Okay, we're good now. So in the section 2.1, we study the tangent, right? It means touching, when a line touch a graph at one point. And we review the slope, which is the change in y over the change in x. Given a slope, we can write the equation of linear equation y minus y1 equal to the slope times the change in x. The velocity problems follow this formula, 4.9 by gravity times t squared. And the average velocity is the change in the position over the change in time, which is s2 minus s1 over t2 over t1. When the time dt goes to approach 0, it becomes the instantaneous velocity, right? Okay, and then in the section 2.2, we study the limits and derivatives. But we're not study derivatives yet, just talk about limits. Okay, the definition of limits is written this way. It means that f of x will approach to capital L as x approach a. So in this, remember this figure, a should approach both sides, right? And the function f may be defined at that point at a or may not, may or may not, right? For example, here, in the first pictures, f at 8 is L, but in the second figure, f at 8 is a solid value right here. It's not L. Or in the third case, it is not defined at f at a. Okay, so this is the whole right here. So a one side limit, it means that x may approach from the left side of a or from the right side of a, right? Like in the figure on the left or on the right here. Very important thing is that the limit at one point is equivalent to the limit should exist. I mean, the left side limit and the right side limit, they should both equal to each other, and they're all equal to L. If either the left side limit does not exist or these two limits are different from each other, then the limit at a does not exist here. Okay. Sometimes when x approach a and f of x may goes to positive infinity as in the figure A, right? Or sometimes x goes from the right side of A and the f of x goes to infinity. These, or maybe it goes to negative infinity. When x goes from both left and right side of A, we call it infinite limits. And this line, when x is equal to a, the purple line here, we call it asymptotes. Okay? Those are what we study together. And these are cases of vertical asymptotes. And remember, in the videos of the book, they mention the Doppler effect. So remember to watch that. And in this section 2.3, we will study how to calculate the limit using limit laws. And these are summaries of that. The first one, the sum of limit, the limit of a sum will be the sum of the limit of the function f and g. We assume that the limit of f and limit of g does exist, right? The second one is the difference, the limit of a difference is the difference of the limit is in 2. And the lim of c times f will be c times the limit of fx. And the limit of a product will be the product of limit. or the limit of a quotient will be the quotient of the limit. And make sure that limit when x approaches a, limit of g is not 0. That is the requirement of a quotient, right? The denominator should not be 0. And a power law, because from the product rule 4 right here, we have the power law limit of f of x to the n will be limit of that to the n. And n here is a positive number. This is this file is already uploaded on Moodle, so we will just go through it and then go to details example, right? So don't worry about that, but it's good to write it down. So limit of a constant when x approach a will be simply that constant, c. Or limit of x when x approach a will be that number, a. And similarly, x to the n, then n is positive integer, then we can do this. And in the properties 10 here, there's n root of x, and n is a positive integer. Assuming that a is positive, then we have this law, okay? And another one, the root laws here, providing that the f of x, the limit it exists, and limit of f of x when x approaches a should be positive, then we can evaluate this. Okay? Now, these are all formula we will study and apply. For now, let us go to each examples. Okay. Now let us consider, wait a second. Okay. Can you see it clearly on the board? Okay. Very good. So the first example, if we're given a graph like this, oops, interesting. Solid line right here, and another graph is this guy at -2 and 2 like this, and here like this. We call this the red function is the g function, and the black function is f function. Right here at this point is -2, -1, and this value is -1/2, and here this guy is -1, and here is -2, and here this is 2, here is 1. Okay, we are given f and g like this. The question is to compute the limit of f of x plus 3g of x when x approaches -2. Limit of f of x times g of x when x approaches 2. Okay, let me scroll down a little bit. C, limit of a quotient f of x over g of x when x approaches -2. And D, let us write it on here. D, limit of square root of f of x when x approaches 2. And E, limit of g of x squared when x approaches -2. So these are the questions. And let us go one by one, right? Look at this. On the graph, at f at 1 is, f at -2 is 1, right? You see? F at 2 here is 2. And this is the solid point. And g of -2 is, g at 2 is -2, this point. Here, the solid point. And, okay, for g larger than 2, it follows this branch, okay? G at -2 is equal to -1/2, like this point right here. Okay, it's clear about the points, right? Now, first, the A, okay? The solution of A. This is the limit of a sum, right? And we can apply the rule of sum of limit. And this constant, we can also take it out of the limit. It means it becomes limit of f of x when x approaches -2 plus 3 times the limit of g of x when x approaches -2, right? Just these power the law. Then f of x at -2 from here will be, see, 1, right? Put it from the graph here. This is 1 plus the number 3 times the limit of when g of x approaches -2, it will be -1/2. So it means this number here would be -1/2, right? So 1 minus 3/2, which give us -1/2, right? So let us move to B, the limit of a product. Limit of f of x times g of x when x approaches 2, right? And we know that from product rule, it is the limit of f of x when x approaches 2 times the limit of g of x when x approaches 2. G of x when x approaches 2. F of x when x approaches 2 is 2, right? We know it right here. But g of x, look at this. When x approaches 2 from the left side, g of x, g of 2 will be -2, right? We know that. Of g of x when x from the left side will be -2, and the right hand limit of g of x when x goes from the right side of 2 will approach -1, right? The different value. These two values are different from each other. Therefore, the limit of g of x when x approaches 2 does not exist. Right? So it means that this guy does not exist times with a number right here. And finally, we conclude that the limit of f of x times g of x when x approaches 2 does not exist as well. Is it clear? Okay. Let us move on to the number C. Here, the limit of quotient when x approaches -2. And the quotient law tells us that it is the limit of f of x when x approaches -2 divided by limit of g of x when x approaches -2, right? And from the graph, look at here. When f approaches -2, it should be 1. And g approaches -2, it will be -1/2. So this quotient becomes 1 over -1/2, right? And we know that this division becomes 1 times reciprocal of this number, right? Flip it. And it is, yes, -2. Is that clear? Very good. Is it too fast? Or, yeah, good. So D, so in D we need to compute the limit of the square root of f of x when x approaches 2. We see that the function f of x is above 0 here, right? In y direction from at 2. So we're good. It is positive. So we can use the root law, which means it will be square root of the limit f of x when x approaches 2. Okay? Then we know that it is 2 at that point, therefore it is negative square root of 2. That's it. Remember, we need to check if f of x is positive. So very important. We know that it is positive, right? That is why we can apply this. Otherwise, we're not allowed to do so. Okay? Here, let us continue in E, limit of g of x square when x approaches -2. Okay, again, g of x at -2 does exist, and it should be square of a limit, right? And which is -1 over 2 square. Negative square, which gives us a positive number, 1 over 4, right? So that's it for that. Some basic law and from the graph. Now let us study another properties, we call it direct substitution properties. Okay, so if a function f of x is a polynomial, for more details, read the book. I just summarized the main idea of the function, right? A polynomial or a rational function, right? And A is in the domain, very important. A is in the domain, okay? Then the limit of the function f of x when x approaches a will be the evaluation of that function at a. Because this function is defined at a, since a is in the domain, therefore we can evaluate it. It's easy, right? Otherwise, we are not allowed to write it. Okay, an example. The limit, we need to compute the limit of this function, 2x squared plus 1 over 2x minus 1 when x approaches 1. Right, find it. First, near 1, we see that this guy, 2 times 1 squared plus a number 1, it means the numerator is positive, right? And 2 times 1 minus 1 here is also a positive number. Therefore, this fraction here should be a positive number, right? So we can apply the root law. Now, this implied limit when x approaches 1 of this function, 2x squared plus 1 over 2x minus 1 is square root of the limit here, 2x squared plus 1 over 2x minus 1 when x approaches 1. Now, and when we put 1 here, the denominator is different from 0. So it means that the function here is defined at a. Or in other words, a does belong to the domain of this function. So from the previous direct substitution properties, we can simply put the value of this, which is 2 times 1 squared plus 1 over 2 times 1 minus 1, right? It is square root of 3 over 1, or square root 3, okay? But sometimes it's not always true. Be careful. It's not always the case. For example, look at this. Here, we consider the limit of x squared minus 6x over x squared, 5x minus 6 here. X approaches 6. So what is the limit of this guy, right? So we see that when x is equal to 6, we have x squared minus 5x minus 6 is equal to 0. It means that the denominator here is 0. This fraction is not defined. Or the x is equal to 6 does not belong to the domain of this guy, right? So we cannot substitute it into this function. So right, we cannot do that. So what we need to do is to simplify it and see if we can come up with a better expression of this function, right? So write it down. Limit x squared minus 6x divided by x squared minus 5x minus 6 when x approaches 6. So we see that in the numerator, we can factor what is the common factor here. Yes, it is x. So we can factor it out. So inside this parenthesis is x and perfect, negative 6. In the denominator, this is quadratic function. Therefore, we see that by experience, we know that it should be x minus something times x minus or plus something else. And this is this number, negative 6, which is 6 times 1, right? Negative 6 times 1. So we know that this factor should have the terms will be 6 or 1. And in this case, it is negative 6 and plus 1. If you don't believe me, just factor it out, FOIL it. You see, FOIL it. We will see that this is exactly this one. Okay? So let me erase this. Okay, now we see that this guy and this guy is the common things of the numerator and denominator. So it cancels each other, right? So the limit becomes the limit of x over x plus 1. X approaches 6. Now, at x is equal to 6, x plus 1 is not 0. Therefore, we can substitute, right? It is defined. So we can simply substitute this, and it will be 6 plus divided by 6 plus 1, which is 6 over 7. Right? Is it clear? Very good. How about people on Zooms? Is that okay? Very good. So now let us move on to another example. So, wow, this guy looks nice. Limit. We need to find the limit of 3 over t times square root of 1 plus t plus subtract 3 over t. Okay, we need to compute this. Can we do the difference law? The limit of a difference is equal to the difference of a limit. Can we do it this way? We cannot. Why? If we put t equal to 0, 3 over 0 is it defined? No. And furthermore, this guy is as well. 3 divided by 0 times something is not defined. So we cannot use the difference laws right here. So this guy is very annoying. How can we eliminate it? Any suggestion? Louder, be confident. Very good. So we see that these two fractions we can add up together, right? But in order to make an sum them up, they should have the same denominator, which is t times square root of t plus 1. It is not the case now, but how can we make it? So if we multiply this fraction by square root of 1 plus t and divide it by the same things, nothing's changed, right? Still it. But now these two fractions has the same denominator, right? So we can add the numerator together. Now, what is it? So this guy becomes, oops. Okay. Come on, yes. Okay, it is the limit when t approaches 0 of. Now, the numerator, subtract the other guy. Divided by the same denominator, okay? Now, look at this. This is 3 and this is another 3. So it is a common, common factor, right? So we can factor it out and see to make it simpler. So if we factor 3 out, inside this, the parentheses here, what do we have? Imagine 3 is 3 times 1, right? If we take 3 out, then 1 is left right here. And the negative side, okay, the negative sign. This guy, 3 times something, we take out 3, then this is left. Okay? Okay, now we're stuck. Anyone help me? We want to somehow cancel it out, right? But this one is square root of something, and this is 1 minus itself. We cannot cancel them. If we multiply by t, let us try. If we multiply by 3t, then we need to divide it by t to make it even, right? How about this one? Let me remind you about this formula. From now on, remember, this is my notation. If I write something inside of this, it means the side computation is not in the follow work. So a squared minus b squared, which is a minus b times a plus b. This is the formula. Remember it, memorize it. So now, this guy, because here, this is square root. If we somehow square it up, then the radical sign will be disappeared, right? So in order to do this, how about let us, this is 3, we just rewrite it. Nothing changed yet. Now, we see that this is negative, so how about if we multiply with 1 plus this guy? And divided by the same thing. Is equivalent to multiplying by 1, right? Nothing's changed. We're still good. But now, this guy times this guy. Apply this rule. So it becomes limit when t approaches 0, 3 times something inside here. And the denominator, we just rewrite it. Okay, here from this formula, this minus this times this plus this, it will be 1 square minus b square, in this case, should be 1 plus t square root here, square, right? Square root and then square will be simply 1 plus t. One square is 1. You should be very careful at this point. One plus t and t plus 1 is the same thing. So look at this. This is the negative side in front of the parentheses. When you remove the parentheses, remember to change the sign of everything inside this parentheses. So very careful at this, because many people got mistake here, and even me sometimes got mistake here, and that makes the whole thing wrong. Remember, let me just, yeah, make it very important right here. And t, 1 plus t, 1 plus square root of 1 plus t. Okay, now 1 and negative 1, they will cancel each other, right? And negative t here divided by t here give us negative 1, right? So now at t equal to 0, this guy will be square root of 1 plus 0. It is defined, which is 1. We are good with that one. Here, 1 plus 1 over 1 plus 1, right? We are good. So it means that we can substitute the value now. Since we can do that, it becomes 3 times, yeah, t will be cancel each other, square root of 1 plus 0 times 1 plus square root of 1 plus 0 here, which is 3 over 1 times 1 plus 1 will be 2, or 3 over 2, right?
So is it positive 3 or negative 3?
Oh, very good. Yeah. You're still awake. So here, remember, this is negative t, right? Very careful. So this should be negative. right here. And here will be negative. And finally, negative 3/2. So be careful with that. Okay? Is there any question as to here? Very good. Now, let us consider another example. Limit of absolute value of x when x approaches 0. And what is it? So, by definition, the absolute function is defined this way. The absolute function will give us the distance from x to the origin of the real line. If the origin of the real line is here and x is here, then absolute value of x will give us this distance. So it means that x or negative x here, they have the same value when we take the absolute value of this, right? It means it would be x for x positive, or negative of x for x negative. So we will continue tomorrow. Okay? Think about this one. And at home, let us write out one more question. How about the limit of go home and think about these two problems. And tomorrow we will continue. You have a good one. Bye all.
Excuse me. I came to the last two class sessions, but I'm pretty sure I was marked down as absent for both of them.
What is your question, Jack?
I came to the last two classes, but I'm pretty sure I was marked down as absent. I just want to make sure I was marked down.
Oh, I cannot hear you. Can you send me an email?
I gotcha.
Okay, have a good one.
You.